Okay, so we're going to look at molar volume now, and these kind of calculations are just the same as like what we've been looking at with excess and the percentage yield, except we're using the next bit to calculate the volume instead of like another mass or something like that. So here's a good wee question. Phosphine is used as an insecticide in the storage of grain. It can be produced by the reaction of water with aluminium phosphide. First of all, let's state the type of bonding and structure in phosphine, which is not this one, it's this one. pH 3, the fact it's a gas and the fact it's two non-metals mean that this is going to be covalent, discrete, molecular. Discrete means it's just like molecules on their own, they're not joined together like a network. You don't have to say the discrete, but your teacher might have told you that. Let's work out the molar, we'll do the molar volume calculation now. Okay, so two things we're interested in are aluminium phosphide and pH 3. So we'll put them out to make the calculation simpler. And we're trying to use the number of moles for our aluminium phosphide to work out the volume. So again, there's going to be 3 steps here. One is to calculate number of moles. Second is to use, I'm going to use the mole ratio. And 3, we're going to calculate the volume. So let's go back to this. We have got, I'm going to zoom in a wee bit so it's easier to see. I think that's as far as it's going to go. 1 mole to 1 mole. We're going to work out the number of moles here, which is N equals mass over GFM. If you'd worked out the GFM, it's going to be 58, and 2.9 kilograms is used. Let's change that into grams by times by 1,000. 2,900 divided by 58 will give you 50 moles. Using the mole ratio now, we can see that that would give us 50 moles of phosphine, pH 3. So all we can do then is we can go ahead and do volume equals the number of moles times the molar volume, which is given in the question is 24. So that's 50 times by 24 will give us 1,200 litres phosphine gas produced. And that is your final answer. Okay, let's try the next one. And I'm not going to talk through this one because it's just the same kind of idea, following those 3 steps. I'll pause here so you can read the question. We can cancel those out, so it's just CH3 OH to CO2. So it's a 1 mole to 1 mole ratio. And it says in the question, if you'd paused it, it's 118 grams of methanol that is used. We use the mole ratio to work out the number of moles of CO2, which is going to be the same. So it's a 1-to-1 ratio. So 3.6875. And let's work out the molar volume, or the volume even. That comes out at 88.5 litres.